Good afternoon, good evening, good morning, depending where you are joining from. Welcome to this webinar. We're about to explore the differences between Design FMEA, Process FMEA and FMECA in a few slides and hopefully give you opportunity to raise some questions along the way. I'm aware people are still gathering, but we will nevertheless progress, and we'll introduce ourselves while people are joining the call. If you could click on, please. So today's webinar is being recorded. It will be available for free viewing on the ASQ website subsequent to this event. And we'll send you all who are attending today a notification when that video is available for you to view and to send to your friends. This is me. I am Rob Farndon. I have worked for Rolls-Royce for 35 years now. I've had a long and varied career, including design practitioner roles. I've been manager roles and specialist roles along the way. I'm essentially at the moment a design process specialist, and particularly I'm a subject matter expert for Rolls-Royce for APQP and PPAP, and particularly the design aspects of defect reduction. As part of Rolls-Royce, I've led the creation of the design process for civil aerospace, supporting a transformation that we made to adopt APQP and PPAP. I'm also, amongst other things, a lead design coach for civil large engines design population. And amongst my history, I led the authoring team for RM 13004 when it comes to the DFMEA content. So if you're reading those words, I am partially to blame, I'm afraid. I'm at the moment a deputy team leader for this subject matter interest group, in the interim fulfilling the role of team leader. That is me, and I will introduce you now to my colleague Lena. Lena, would you take the next slide, please?
My name is Lena Eckerbom-Wendel, and I worked for, when I started there, Volvo for 30 years. Now it's GK and Aerospace, still the same company though. I started as a materials engineer and moved over to quality lead in development programs, and further on to different specialist roles related to the design system. So I have experience from product development projects, both from a type certificate holder context, but also as a design responsible supplier. So I sit a little bit on both sides when it comes to describing these requirements from the AS 13100 perspective. Currently, I work to be my work is to be responsible for the design system requirements within GK and Aerospace, and also the related airworthiness requirements. So my job is to make sure that our design system meets the requirements from the Swedish military aerospace agencies, since we are design type certificate holder for a military engine there. But my job is also to make sure that our design system meets the requirements from different customers and on the design side, and that it's possible for us to accept design work performed by a design supplier. I lead the team for RM 13004, the subject matter interest group for design work. I'm a team member of Rob's 13004 subject matter interest group, and I'm the focal point for design related content in AS 13100. So that's me.
Thank you. Okay. So as we see here, we have over 100 people registered for this this webinar call. We do straddle an awful lot of the globe, so you're very welcome, and we hope you will join us at future events as well. But please do pay attention as we come to the end of this. We'll signpost some of those coming events for you. So I'll be taking you through most of the slides today. We're going to start with a little bit of an understanding of what these individual tools are. And from there on, we're going to explore their integration within the process and the part they individually play inside the process. So first of all, the different types of FMEA. We'll talk today about design FMEA, process FMEA, and something which we're going to present as being related, but actually quite different in many respects, which is the FMECA, or System Safety Assessment, as some people will know it. The primary objective of FMEA, whatever the type, is to improve the product or the production process. So that's what DFMEA and PFMEA are essentially about. They're improvement tools to the design. For design, the design FMEA is to prove the design of the system, the subsystem, or the component, whatever scope you put around the design FMEA. And for PFMEA, it's to improve the manufacturing or assembly process or overhaul process, whatever you're performing the analysis on. FMECA is a little bit different. The objective is actually to enumerate risks, right? To actually provide some substantial evidence of the level of risk associated with the operation of the product. So it is different in that respect. There's less subjectivity in a FMECA, but we'll come on to some of those key differences as we go through. Could I invite Lina to make any further comment first of all?
Yeah, on that slide. So yeah, the spelling is a bit too similar when you come to the design FMEA, DFMEA, PFMEA, and FMECA, same letters in slightly different order, and it's quite simple to confuse them. Historically, on the aerospace side, we were coming from the system safety assessment using FMECA as a tool, and then adding on the DFMEA and PFMEA as new tools. Compared from an automotive perspective, where you come from the DFMEA and PFMEA, and then have added on the system safety aspects of it. So we use the tools slightly differently in different businesses, which makes this even more complicated. But they will try to sort this out during the rest of the webinar.
Hopefully so. Thank you very much. Yes, if we could have the next slide, please, which is just going to pick up on the DFMEA side of things for now. As I mentioned before, the primary objective here is to improve the product design. Okay, we're trying to improve the product design, and we're doing that by trying to identify and eliminate or mitigate design errors. That's what this is about. It's about trying to prevent an error in the design impacting the customer. But it has a very tightly defined scope. We're only considering the design inside the design FMEA. So we're going to lock down and assume that the requirements that we're given as an input to the DFMEA are correct. Okay, outside the requirements we're given are correct. And we're going to assume as well that the product is going to be manufactured, maintained, and operated in exactly the way that we want it to, in accordance with instructions. And the reason is, the reason for that assumption is that there are other tools that are going to deal with the risks associated with it not being operated, manufactured, maintained in accordance with the instructions. So we're very much focusing inside the design bubble here. We're trying to evaluate the design and work out where errors might lead to a deficient product. And by that, I mean how the design might fail to meet the customer requirements. So an easy thing to try and remember the difference between some of these tools is actually to look at the first letter, okay? Because the first letter tells you what might go wrong, what we might get wrong. So in a design FMEA, we're looking for the design being wrong. And all the causes in the design FMEA are associated with the design itself, okay? This is a tool that we're going to use during the design phase predominantly, okay? While we're actively designing something, we should be keeping the DFMEA up to date and using the DFMEA as a means of improving the design or our verification activities. So really, that's its main purpose and place within the overall process. But you can reopen it, and it's appropriate to reopen the DFMEA when something changes. Okay, so if the operating environment changes, the requirement into us as a design organization changes, that is a perfectly good reason to reopen a DFMEA and again reevaluate whether or not that design might satisfy the requirements. Okay, but it is intrinsic to design. As such, the occurrence ratings and all of the scoring mechanisms that go with the DFMEA actually mean very little outside of the DFMEA. They inform other processes, sure, but they are not absolute hard and fast numbers that relate either to the safety or the reliability or the quality of the product. They're just an indicator that indicates where we need to focus to improve the design. Lena, do chip in if there's anything else that you would like to point out.
Yeah, it's also a good thing to start a new way of looking at things. If you do a major change or a significant change to your product, then you should always look on the DFMEA again to restart, seeing if there is something we can, if there's a risk for us to do an error when we're designing that change to the product.
Thank you. Yeah. So really the DFMEA is the designer's friend. It's looking for ways in which the designer can improve their design. And that's its primary purpose. Could I have the next slide, please? So we're now moving on to process FMEA. And here, of course, we're aiming to improve the production process. We're trying to actually identify, again, and mitigate risks from errors in the manufacturing process definition. It's not necessarily about when the process itself goes wrong once it's been created, but it's how we define the process, how we set up the process to deliver a good product. And again, we're going to do a lockdown outside of this process bubble now. Okay, we are looking for errors in the process definition. So that means we're going to assume in this case that the design is right. The design is right. So we're handing a good design record, a proper product definition that satisfies all of the customer requirements. And what we're trying to do here is evaluate the manufacturing process and find errors which may lead to the product at the end of the day not satisfying the specification, the product definition, the detailed drawing that we're looking for. And again, we're going to keep this thing live as long as we're thinking about the development of the process. That could be quite a long time, but it's a living document, is meant to inform how that process is set up. So we're going to use it to evaluate every process step within the manufacturing process and look at how it realizes all those design characteristics that we have in the product definition. And we're going to look for potential causes of failure of the process to deliver that specification accurately. And again, we're trying to mitigate those and minimize them so that we don't pass a fault further on. Lena.
Yep. And if you read the AS 13100 and the RMs, there's an expectation to have information from the DFMEA to the PFMEA. And the important thing there is to make sure that you have sufficient knowledge about the product and the way the product is designed to make sure that the PFMEA has the context it needs, so you know what is important. So to be able to produce conforming parts.
Yeah. So for certain, I've spoken about, and it's correct to draw the right box around these activities. In a PFMEA, you should never consider the potential even that the design has delivered you the wrong design. Okay, so it's appropriate to draw that box around it, but these tools don't operate in isolation from one another. There is information flow, and both tools should be correctly executed within the context of the program team with a cross-functional collaboration between design and manufacturing engineering. Okay, so just because we've said we're putting this box around what errors we're looking for doesn't mean there's no interaction here. It is cross-functional, and it is actually receiving handoff of information from one another. Okay, so we'll come back to talk about this in a later slide. Thank you. So can I have the next slide, please? Okay, So here is a profoundly different one. Some would say it's not profoundly, but it's a supporting activity. What we're seeking to do in a system safety assessment, a FMECA, is a type of system safety assessment, but we're trying to enumerate risks associated with the operation of the product in the customer's hands. It may have an impact on the processes that we've just talked about, DFMEA and PFMEA, but it's more by way of having, if it identifies a particular issue, it can feed back into those. Okay, so failure modes that have historically been seen in a FMECA could feed into a DFMEA, for example. But the primary objective of this FMECA, failure modes, effects and criticality analysis, is to investigate the product risks and evaluate the product risks and try and determine whether or not the level of safety that's inherent inside the product in service is acceptable for the product in service. So that being the case, again, we're going to put a box around this analysis process, and we're going to assume that the product design is without errors. It meets all of its requirements. That's what we're going to assume. And we're going to assume that the product is correctly manufactured and is completely conforming to the product definition that comes out of the design office. And what we're going to do is basically take that conforming product and evaluate that product at the aircraft level, at the operational level, at the super system level, if you like, and focus on the entire life cycle of the product. We're looking for calculated rates of failure and identified levels of impact from that. And we're going to express these numbers on a basis of numbers of failures per flight hour or an equivalent. And again, because it is concerned with safety of the product in operation, the FMECA should live throughout the life cycle of the product in operation. Okay. And it should be a very thorough analysis. It should look at every function and every potential failure mode and every potential cause of those failure modes in order to evaluate the overall safety level of the product that we're looking at. Yeah.
And yeah, this is a requirement for the type certificate holder to be able to assess the numbers of different types of product failures. But for design responsible supplier, can you do an FMECA? Yes, you can. With sufficient information from a customer or the design accountable person, organization, you can have enough knowledge to assess your product and what the contributions of your product would be into your customer's total risk assessment at system level. It might be that you don't have the exact numbers. It could be that it's a high risk or a low risk, but it still helps in the overall system safety analysis for the product when used.
Thank you. So one thing to pull out here is that whereas in our subject matter interest group for defect reduction, we do tell you how we would like you to do a DFMEA and a PFMEA. Okay, we're not going to tell you how to do a FMECA, because FMECA is governed by a different set of standards that are determined by some ARP standards that are a little bit to one side of our scope. That's fine, okay? I think what we're trying to do here is explain the role of that process in the overall process so that we don't get DFMEA and PFMEA confused with FMECA, because it is there for a different purpose. Okay, could I have the next slide, please? Okay, so we're now going to try and draw some lines, some demarcations between FMECA and DFMEA. And this is the most simple way we came up with of trying to lay out that picture. It's just some simple bullet points. I'm going to start with DFMEA and then contrast it with FMECA. So I'm going to ask you to, I know it's not intuitive, but look at the right-hand side of the screen first. Okay, so DFMEA is something we perform in support of APQP and PPAP. It's something that's part of that defect reduction suite that tries to ensure that the customer is satisfied. And we're going to use it to focus on the identification, prevention of errors, either in the design or in the production process. And we're going to derive some estimated risk priority levels in order to inform where we need to focus our error reduction activity on. We're trying to do robust design here, and we're trying to identify good verification plans that either inform the design as it evolves or confirm that we have actually met the requirement, which is the principal purpose of verification inside the design process. These activities, DFMEA particularly, is done very early in the product design process. Okay, very early in the design process. The earlier you can start it, the better off you are, because that means the earlier you can identify those errors and the earlier you can eliminate them. It is a design-led task, but it's a design-led task that requires an awful lot of support from the broader team. It requires product support engineers, it requires systems engineers, it requires manufacturing engineers to be on board, and safety and reliability expertise. It requires various things. And it can be done either as a top-down or a bottom-up exercise, so that you can just take a design and imagine failures of that design to its local requirements, and imagine what the cascade of failure modes is up from that particular mechanism. Or you can come from the top down and say, here is a set of requirements on a component. Please evaluate for me whether or not you can meet those requirements. So that's DFMEA. Now let me contrast that with the FMECA position, okay? And then I'll invite Lena to comment. Here with FMECA, we're not trying to support the design. We're actually trying primarily to support the safety assessment of the product afterwards. It's kind of like a form of verification, if you like, of the safety level that we're looking for. And actually it focuses on physical failures and physical effects propagations inside the delivered product in operation. Right, so it's not a desktop exercise like DFMEA, which kind of tries to dream up failure modes that may occur if we get the design wrong. This is actually saying, well, what if that product did fail? How could it fail? What would the impact be? And we're trying to come up with some concretely predicted failure rates in a FMECA. That means that we're trying to have something there, a number that we can stand behind, that has some data integrity to it, and some substantiation to that number, such that we can trust it for the life cycle of the product and to predict accurately the safety level of the product. And as such, it's used as a great support to certification objectives, right, where we have to demonstrate a level of safety in our product. I'm going to complete this analysis really on the designed product. You can do one early in the process, and that's fine. But the other thing is that it's a safety-led task rather than a design task. It takes different skills, right, to the standard design engineer to do a FMECA. And it essentially is a bottom-up analysis where postulated failure mechanisms are traced up through the system architecture. And we have to evaluate not just the potential for the mechanism, but for the propagation. So it's a different discipline altogether, and it has different aims that we're looking for. Lena, do chip in.
Yes. In the AS 13100 and the APQP standards, we talk a lot about DFMEA. And we just say that FMECA and system safety is something different. Don't confuse those two. And this slide and this description by Rob was an attempt to pinpoint what are those differences? Why are they different? What do they do? To give some more details to that statement. They are different, and just stopping there.
Okay, thank you. Could we have the next slide, please? Okay, so DFMEA and FMECA, and whether or not you do a DFMEA or a FMECA or both is determined, at least in part, by the context in which you're operating. Okay, so if you've got a design with very many features, you are likely to need a FMECA as well as a DFMEA. And the reason for that is that the FMECA tells you an awful lot about the system behavior should your component fail. Okay, because those failure mechanisms and their propagations up to the platform level are highly dependent upon engine architecture. And for that reason, FMECA tends to go with the design responsible body, the design responsible organization. We talk a lot about the customer system here because that is what really determines the impact of an individual component failure. And that is something that you won't necessarily know if you're a supply or a design only organization of a component rather than the system. FMECA tends to be later in the design process because it needs the design and its architecture in order to do an effective analysis. Okay, so if you're early on, you may be better with bottom-up DFMEA activities or something like that. So DFMEA is best executed when you've got a tightly bound problem, a tightly bound set of requirements, fewer features. It's not to say that you can't do a DFMEA on a very complex product. You can, but you tend to spend a lot of time talking about failure mode propagations and system architecture in those discussions. So where you've got a lower system dependency, DFMEA is probably more effective. When you're earlier on in the design process and perhaps you're trying to evaluate your concept at the component level for potential failure modes, that is where really doing a DFMEA and trying to dream up what can go wrong yields benefit. But a FMECA doesn't really sit in that sort of space. It sits in higher complexity and looking at a big system. Lena, it's your slide. Would you like to comment?
The reason for this slide is that we had a lot of discussions in the AS13100 writing team about, is it possible to do an FMECA as a design responsible supplier? And some were very confident that it's not possible. And others were as confident that it is possible. And then we realized it depends on what type of product would that design responsible supplier be designing. So if it is something that is complex, that is highly dependent on the engine architecture, you get the requirements for that product very late in the development of a new engine, then you need more of an FMECA to be able to support the design accountable party with the information they need to do the system safety assessment on their level. But if it's very simple to set the requirements, not necessarily to do the design, then the DFMEA helps you to find the design errors and how we find what are the risks not meeting those requirements. It does not say that the design work is more or less complicated, but it says more about how the context of that design work is set up. So after a bit of discussion, we ended up saying that it's possible to use both the DFMEA and different system safety assessment tools as a design responsible supplier, but they do different things.
Thank you. So at this point, we're just a little over halfway through the webinar. So I'm going to encourage you, we're going to move away from the individual tools now and talk about the overall process flow. But if you've got any questions arising from the slide so far, do pop them into the chat and we'll try and scoop them up a little bit later on in the presentation, if that's okay. Could I have the next slide, please? So this is the way that the defect reduction tools are presented as a system inside RM 13004. It's a picture that we've worked up to try and demonstrate some of the connectivities between the tools and their role within the overall process. It's not pure, okay? And you could draw this in a number of different ways, and we do debate that. But effectively, the big message here is that each of these tools performs a risk reduction activity on an individual part of the process. DFMEA and PFMEA have their own individual role in improving those activities. But if you do one of them and you don't do the others, then you end up with potentially missing stuff, because these tools talk to each other and support each other. There is an information flow implied. And that is one of the reasons why we encourage people to do these FMEA tools in a collaborative way. You must apply these tools at the right time and the right place in the overall process. They can all apply at multiple system levels too. They must be deployed in a cross-functional team. And actually, if you do them together, they become more effective individually. Okay, you will notice that FMECA isn't actually on this slide, but the way I've chosen to represent that is to actually point FMECA at the verification, because essentially in the context that we're talking about, the FMECA is a verification, an evaluation of the safety level inherent in the product that we finish with. Any comments from you, Lena?
No, you did that very well. It's a system. We have different pieces of the puzzle. They all have their specific purpose and they do different things. And we can't say that one is better than the other. But we need all of these tools to get a defect-free product at the end.
Thank you. So we're trying to, oh, sorry, could I have the next slide, please, Ralpho? Thank you. This is looking at the overall process flow and the connectivity between these tools in a slightly different way. Essentially, we're going in this picture from customer requirements over on the left to the delivered data, if you like, over on the right-hand side. And we're following effectively, if you look at this carefully, you will see three primary value streams of information. There's some technical requirements that we capture, and then we do verification planning and verification activities. And then at the end of the process, when we've done the verification, we'll report the verification, and that goes off as evidence of compliance. So within the design organization, that is the requirements and verification strand. Out of the requirements, we will extract product functions, and the product functions are really important because one, they tee up the DFMEA. You need the product functions as an input to the design FMEA. The design FMEA will identify problems potentially with the design, and that will lead to activities to improve the design. It could also lead to activities to improve the verification plan at the top of the picture. Again, these tools talk to each other. When we've optimized that design, we create a product definition, and of course the product definition is the thing that really goes into the production organization, and they pick it up from there with the PFMEA. Okay. The thing that's happening in the middle is that system safety assessment, and there's a bunch of tools there that do with the safety level inherent in the product, and of course they need the product functions and input as well. The FMECA, when we have it, can suggest potential functional failures of the product, and that feeds into the DFMEA as an idea. There are new lines suggested in the DFMEA from that. And also we need to try and keep developments of the design in step with the system safety assessment. Because we need the system safety assessment to inform things like classification of characteristics and the part definitions themselves. So that is influential in setting up the CIs and KCs inside the product definition. We showed a double-headed arrow on that. I think basically the design can inform the FMECA and the FMECA can inform the design, and it's appropriate that they do so. Lena.
Yes, I want to take the opportunity on this slide to also talk a bit about another subject matter interest group, not the one with the defect prevention quality tools, who issues the RM 13004, but also the design work subject matter interest group with the RM 13008. The different elements in this picture would be from the design technical data package that is mentioned in AS 13100, but has more details in the RM 13008, which is also available on the ASQ website.
Thank you, Lena. That's a good advert for another interest group. Could I have the next slide, please, Rodolfo? And this is really just to try and draw things back to some form of conclusion. These tools are good. They help. They do drive defect reduction. They do help to understand the quality and the safety in the product as we deliver it to the customer. But it's easy to get lost in these individual tools. Okay. When you're filling in a form or a spreadsheet or however you choose to do it, performing a DFMEA can be quite a dry activity. But it is a focus of those activities to look for improvements to the design or the process, and it needs to be a cross-functional team performing that. It's not just about filling up lines, is the end message. We need to focus the DFMEA and the PFMEA on those activities that will really drive the improvement to the product. If you can't see the point of a line in a DFMEA or a PFMEA, probability is it doesn't have a point, right? So make sure you're getting the value out of this by operating with the right mindset to seek out those defects and to try and eliminate or mitigate them. Thank you, Lena.
Yeah, so you might have really good software. You might have a perfect database with a library of different types of risks. And in the PFMEA aspect, that is probably a very good way to start. If you're going to drill a hole, you know what could go wrong in drilling a hole. The thing is, on the design side, we want to find the risks that have never happened before. So then it's even more important to have the cross-functional team discussion and not focus on quickly filling out the forms you can, because it's something you need to submit to move to the next design review or the next project gate. So here you want to find the things that we never saw before. And then it might not be a good thing to have someone else doing it outside of the design team, filling out a template with a perfect library of different risks, but have the meeting, talk to each other, use the experience, listen to each other to find the risks we didn't see before.
That's it. Thank you. Okay, could I have the next slide, please? And this is really trying to come to the end of the presentation now. We're going to signpost for you where you can go for additional help and guidance on this topic or anything to do with RM 13004. The reference manual is your starting point, and that is available, of course, free of charge from the ASQ website. We do also offer FMEA training available through the SAE, so do have a look for that. And we, of course, we run our subject matter interest group to support the deployment of these tools, the DFMEA and the PFMEA that we talked about here. And you can access that subject matter interest group through the ASQ website. If you just move on one slide, please. Okay. That's how you navigate to it. So you go through the landing page of the ASQ into the link for the subject matter interest groups, and then you will be able to find the RM 13004, the defect prevention page. That will also take you to the LinkedIn group, where you can submit any question anytime you like. So coming out of here, obviously we'll take questions just now, but if there's anything that occurs to you later on, please do use those functions inside the LinkedIn to actually post us questions, and we'll of course attempt to answer those as they come to us. Have the next slide, please. Right. Okay. So coming events. The dates for these things aren't yet fixed, but do watch on the website for information about the following. But there's going to be a webinar about using process flow diagrams and characteristics matrix as an input to the PFMEA. We're going to cover something about action priority methodology to prioritize actions for PFMEA as well. And there is something of a collaboration between the APQP, various groups, let's say various interest groups, to show a flight path through APQP, building process control within the overall manufacturing process. So that is something that we're starting to work up now. Could I have last slide, please? Well, thank you all very much for attending. I'm just going to pause for a moment. If there's anybody who wants to raise a question now in the chat, please do so. Lena, is there any other observation you want to make at this point?
No, just to say that if you missed this opportunity to write something in the chat as a question for us right now, the community of practice is there. So it's possible to initiate a discussion anytime. So, and I would look forward to having discussion in there.
Yeah, thank you. Yeah, do use those means. Okay. I'll just open up the chat and give it one final check. Is anyone typing? Okay, it's a question there from Dan. He says, how does FMECA address redundancy? Do you want to take that one, Lena, or shall I have a go?
You can start, and then I'll chip in if I feel I need to.
So FMECA, I should hasten to add, I particularly am not an expert on product safety. I'm an expert on design, right? So FMECA is an activity that's generally performed by the safety community within an organization. How does FMECA address redundancy? Well, it's aware of system architecture. It needs system architecture in order to function, FMECA, because you need to, having imagined a failure mode of a component, you have to trace it back up through the system architecture. Now, if there is a redundancy inside the system architecture, of course, the failure mode will propagate so far and then will be unable to propagate past a redundant structure, etc., which downgrades the impact of the failure. So FMECA does address redundancy, and it does it by understanding of the system architecture. Similarly, if you have a DFMEA that has a failure mode, we're talking about a bottom-up identification of a failure mode and effect here. You need, in order to be effective inside a DFMEA, if you're going to work out what the severity is, what the system level impact is, you need to understand the system architecture, because a redundancy in a structure, let's say, will downgrade the effect that a particular failure mode has. Okay, but you won't assume that both routes in a redundant mechanism fail at the same time necessarily. There may be some evaluation of that inside the FMECA. Yes, Lena, any further onto that, or will that do?
Yeah, I can add a little bit more, saying that, yeah. So the FMECA could be a tool to pinpoint if we need to do more work to reduce the risks. And one could be to introduce redundancy that wasn't there primarily in the architecture. So in that way, it's a tool to affect the product design. And this is not really a training in how to do an FMECA, but to describe the differences and how it fits into the system compared to the DFMEA. So yeah.
Okay. There is another question come in, which is, can you go into a little more detail about how FMECA evaluates safety compared to the rating scale FMEA assigns, based on expected outcome, loss of primary, secondary function, failure without warning, etc. Well, I think the thing we would say is that the numbers are not unrelated, but they are different. Okay, so the severities might well have a close relationship with each other. You're thinking about what the impact of a particular failure might be. The occurrence, though, is very different. Inside a DFMEA, what we're really talking about is the effectiveness of the design controls within the DFMEA. So that means that we're trying to evaluate those design controls as to how effective they will be in removing a design error, right? So consequently, the occurrence in a DFMEA has to do with your confidence in the design, not in a failure rate in service of the product. And that is a key difference in the enumeration inside of FMECA versus an FMEA. You're also trying with a FMECA to evaluate, as you are in a DFMEA, that the likelihood of the progression as well as the likelihood of initiation of a failure. And that means that the redundancy argument that we just had, for instance, comes into play in that sort of way. But I would say, of course, the system safety assessment is primarily concerned with safety-related failures rather than necessarily loss of secondary function or customer annoyance and things like that. Of course, they are a topic for reliability, but the FMECA, I guess, when we brush most with it in design, is talking about safety-related failures. Yeah. Lena, any comments?
So the FMECA would be a tool in the system safety assessment, ending up with a number on what is the risk per flight hour for a certain type of engine event. So it would influence how you design your part to reduce that risk. On the DFMEA side, a typical action could be that we do 3 more analysis with different analysis tools to make sure that we have a better confidence and a better design control. So they are, it's the same type of product failure, but we have completely different time frames, completely different mitigation to reduce those risks.
Okay. Any further questions in the chat? I think I don't see any evidence of anybody typing. So in that case, I think we'll probably draw the webinar to a close. I'd like to thank you all for attending, and I'd like to thank Lena again for joining me in preparing for this one and delivering it. And yeah, do follow up with any further questions through the LinkedIn channel that we have, and we'll look forward to see any comments in there. Of course, the recording will be shared on the website, as will the slide deck from today. So that will be available to you also. If there are repeated questions that come up again and again, we'll probably put together some form of frequently asked questions. Okay, but for now, we'd like to say thank you very much for coming along.
Thank you very much.
Thank you.